The assignment was on page 334. It was the review exercises. Seems like we were doing pretty well with the first 5 or so. And I can answer questions tomorrow on that. But I'm going to do number 6 through 10 right now. And don't forget, we're going to have a practice test tomorrow. And then the real test is on Thursday. Hey, I've been working on an intro. It's not ready yet, but I promise when you see it, it is going to knock your socks off. You're just going to be watching it and like, pow, pow, socks, gone. Okay, but for right now, let's get started with the first question. I think I'm going to do question number 6. Here we go. Okay, here's the question, and I'm going to draw while I talk. So Ramon has applied to 2 schools, and he has applied to Princeton and Stanford. Now he has a 40% chance of getting into Princeton and a 50% chance of getting into Stanford, but a 20% chance of getting into both. So Stanford is right there, and then Princeton is right there, if you remember. Okay? So, sorry, 0.2, 0.2, 0.3. See? So we've got 0.5 for Stanford and 0.4 for Princeton and 0.2 for both. Okay. But don't forget, what about neither, right? What do all these things have to add up to? 1 total. So 4 plus 3 is 7. So we got a 0.3 out here is that neither school is going to invite him in. Okay, so let's see. Looks like I answered all the questions. Okay, here we go. Neither school, right? And what's the probability of at least one school? That's all the stuff in here, so that's 0.7. All right, let's go to the next question. Okay, I'm assuming that you read this question, and it has to do with steroid use. So it says that 10% of the athletes, so let's just say the athletes, right, are here, and 10% have used steroids, so 0.10 have used steroids, which means 90% did not. So, how about this? Steroid, no steroid. All right. Now, it says in the problem, let's see, the test is accurate 95% of the time when an athlete has taken steroids. Okay, so if they took the steroids, which is right here, the test is 95% accurate. All right, so it's going to be 95% accurate, so that's going to be a positive result, and then 5% of the time you're going to get a negative result. Okay, now it also says, let's see, it is 97% accurate when the athlete has not taken steroids. Okay, so this situation right here, 97% accurate. So the accuracy is in the fact that if he didn't take steroids, he would not test positive, right? So he would get an accurate test of a negative response, and then 0.03 is the fact that he tests positive. Okay, there's the tree diagram, I think. Let's look at the rest of the question. So the next piece is, what is the probability that a random athlete gets tested positive, whether they've taken steroids or not? So this is a positive result right here, and this is a positive result, so we just add them together, and the answer is 1.22. 0.122 when you add those two together. Okay, so there's about a 12.2% chance that they will test positive. There's that. Let's go to the next one. Okay, letter C says, suppose that a chosen athlete tests positive. What's the probability that he or she actually used steroids? Okay, so I always have to read these a couple times. Provided that they test positive, the probability that they use steroids. So that's that's that conditional probability, right? So let's just do this. It's the probability, right, that provided that they test positive, what's the probability that they actually use steroids? There it is. Now, how do we do this again? So it's the fact that they use steroids and they test positive over the fact that they test positive. So it's the probability of this, actually, right? The probability of this over the probability of this. Okay, so we already know the probability of testing positive. That's this answer right now, or right up here. Now let's see. The probability that they use steroids and test positive. So I think that's just the 095, right? Use steroids and test positive right there. Okay, hold on. Yes, I was correct. So this boils down to, what is it? So this is the fact that they test positive, which is 0.122, and the fact that they, whoa, slow down. So we look at this line here. So over here we're going to have a 0.095, divide those, and the answer is 0.7787. So there's a pretty good chance that, provided that the student athlete use steroids, that they're going to get a positive result. Okay, there's that one. Let's go to number 8. Let's look at this one this way. What is the probability that we get a pizza with mushrooms? Okay. So it seems like there's 2 pizzas with mushrooms with thick crust and 2 pizzas with mushrooms that are regular crust. Anyway, 4 total pizzas with mushrooms. So 4 out of the 7 pizzas, right? And now let's look at this second part. Okay, so provided that it's got a thick crust, what's the probability that it also has mushrooms? So this is our condition, right? Conditional probability. So of the pizzas that have thick crust, how many have mushrooms? And it is 2. 2 out of the 3 thick crust pizzas. Whoops. 2 out of 3. Okay, so what about independence? Well, if they were independent results, right, if one has nothing to do with the other, then they should be equal. In other words, this event right here, this mushroom, and over here, this mushroom, who cares whether it's thick crust or not? If they're independent events, they would be equal. That's a good thing to remember, okay? This and this, they have to be the same if they're independent, because they don't affect each other. All right, there's that. Okay, the next part of this problem is like, what if they put in another pizza? It's a thick crust cheese into the mix. Well, let's see, the probability that it is mushroom, right? They added a pizza, doesn't have mushrooms, so there's still 4 mushroom pizzas in there out of the total of 8. Okay, fine. Now, what about this? The probability that given it's a thick crust, the probability that it has mushrooms. Okay, well, the one that they put in was thick crust, so now there's 4 of them that are thick crust. Still 2 have mushrooms, because the one that they put in was a cheese. Okay, so 2 out of the 4. All right, so that shows that they're independent now, because these 2 probabilities work out to be the same. Okay, so if you put that next pizza in there, it kind of messes things up in a way. Now it doesn't matter whether it's got mushrooms or not, or a thick crust. So there's that. Okay, here's the deer problem, number 9. I took kind of a fuzzy picture here, but I always like doing this. I always like getting all these totals first. That's the marginal distribution. So let's see. What is the probability that a randomly selected seedling is damaged by deer? Okay, so, well, it's right here. These are all the damaged trees, right? 209 out of the total. Nice. I'm glad I did that marginal distribution. 209 divided by 877. The next one wants, for each of these categories, right, it's a conditional probability. So provided that they have no thorny cover, what's the probability that they get damaged by deer? Provided that they have no thorny cover, damaged by deer, 60 divided by 211. So what's the probability that provided that they had 1/3 coverage, that they got damaged by deer? Here it is. Provided that they had 1/3 coverage, that's how many got damaged by deer. So it's the probability is 76 divided by 234, and so on and so forth. So let's go on to the next one. And the third one is, well, interpreting your results, basically. So based on this, the coverage, is there a higher probability one way or the other? And it turns out that this is the highest probability. So if they have no thorny cover, they have a higher probability of getting damaged by deer, and it's actually less as the higher you go. Okay, so the more coverage you have, the less damage you're going to get by the deer. At least that's the probability. So there's that. Let's go to the next one. Okay, so our next problem is about the stock market. Oh, check out our leaderboard for Wall Street Survivor. Now, looks like Riley Mitchell has been big time in it in Dubai, so probably has some oil futures or something like that. Anyway, here's how I'm doing. Yeah, so I'm pretty bad at this. Look at all these companies. These are great companies, and they are all tanking. Who loses money on Apple? I do. Okay. Anyway, seriously, Pepsi. That's like, you can't. Whatever. All right. So on this question, let's go to this question. Okay, here's our tree diagram for this situation. I know it's kind of messy, but here are our 3 years, right? First year goes up or down, right? Second year goes up or down. Third year goes up or down. So if the first year goes up, the second year I have 2 choices, right? So we have all these different combinations. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I figured. Because it's 2 to the 3rd power. That's how that works. That's how it tells you how many options you have with this binary situation. Anyway, but let's take a look at this thing. So this is the branch you follow for increasing all 3 years. Increase, increase, increase. And that's the only one that does that. So the answer for the first one would be 0.65 to the 3rd power. Okay, there's that. What's the next one say? Well, the next one says, well, what about going down 3 years in a row? So either direction, either all up or all down, right? This way or this way. So the answer for that one would be 0.65 to the 3rd plus 0.35 to the 3rd. Okay, that would give you that result. There you go. Okay, I don't feel like doing number 11. Okay, see you later, bye.